20, and it's further along than that. It's 24th. All right, we're going to call this reasoning and conditional statements.
What happened to inductive?
All right, inductive reasoning. Uses a number of specific examples to arrive at a conclusion.
Would using the word common sense be inappropriate?
Inappropriate?
Yeah, like.
Yeah,
Okay.
because it's not common sense.
Yeah.
Now, I'm going to kind of explain what I'm trying to give you these definitions of, and if you want to adjust your definition accordingly, that's fine. What they're really talking about, and you're going to get directions that say use inductive reasoning to make a conjecture. Bunch of what sound to be fancy words. But if you're given a pattern of 2, look at the pattern, 2, 4, 6, 8, and they ask you to, here's how you may hear the question worded. Use inductive reasoning and make a conjecture about the next 3 numbers in the pattern. What they're saying is to look at the pattern, all right, and in this case, these are specific examples. The numbers are 2, 4, 6, and 8. All right? Making a conjecture is describing the next 3 terms in the sequence. A concluding statement reached using inductive reasoning is called a conjecture. So in this case, what would your conjecture be? 10, 12, and 14. All right, so the way you see it, or the way I see it, is I looked at the pattern and I figured out what it was, and then I applied it and I got the next 3 numbers. Or, yeah, it's a list of even numbers. Or it's add 2 to the previous term. But it's called using inductive reasoning to make a conjecture. Okay? That's what you have to understand. So, conjecture. And we'll call that a concluding statement or a statement reached using inductive reasoning. Everybody okay with that? Inductive reasoning, conjecture. Those terms, you have to understand what they mean and what they are. There's not a whole lot to it, but it sounds fancy. Say again?
That was way simpler than like the inductive reasons like super on
I know. Page 94, up on the top. To show that a conjecture is true for all cases, You must prove it. It only takes one false example. To show a conjecture is not true. A false example is called a counterexample. A counterexample. All right, if you look at the right below find counterexamples, example 4 on the top of page 94, it says find a counterexample to show that each conjecture is false. And they give you one conjecture, and they give it to you in the form of an if-then statement. If n is a real number. If n is a real number, then n squared is greater than n. A counterexample is a false example, is a statement showing that this is false. All right? So they say when n is 1, the conjecture is false. Okay? So a counterexample, well, I'm just going to say a counterexample, would be, you could just say when n equals 1. That's a counterexample because 1 squared is not greater than 1, is it? All right, 1 squared is 1, so this is not greater than. So there's your counterexample to this conjecture.
To make that conjecture true, it would have to be greater than or equal to.
Greater than or equal to, yes. So understand those 3 terms from that section, and that's about it. Because then we're moving on to top of page 107. Top of 107. A conditional statement. Page 107. A conditional statement is written in the form and if then. A conditional statement is written in the form if then. So that key concept, conditional statement, that table there is very important. And it's really the way that you can remember everything we're going to do today and tomorrow. So I'm going to try to I'm going to try to modify it a little bit so that it fits in your notes a little bit easier. So let's say that if-then statement. We're going to say if-then statement. The symbol for it. The symbol for an if-then statement is lowercase script P, arrow to the right, lowercase script Q. An if-then statement has two parts, or a conditional statement has two parts. It has a hypothesis. It has a hypothesis. The hypothesis follows the word if. The hypothesis always follows the if. The symbol for hypothesis is the lowercase script p. The second part of a conditional statement is the conclusion. And the conclusion follows the word then. And put comma when applicable. The symbol for the conclusion is the lowercase script q. The model for all this. They call it the model, but it ends up being a Venn diagram. In this Venn diagram, you've got, here's your symbol for your conditional. This symbol reads if P then Q. If P then Q. Your hypothesis is in your small circle. Your conclusion is in the big circle. There's a couple of examples at the bottom of page 107 we need to look at. Example 1A asks to identify the hypothesis and the conclusion. This is as simple as it gets. Identify the hypothesis and conclusion of each conditional statement. In statement A, if the forecast is rain, then I will take an umbrella. What's the hypothesis? No, the hypothesis is what follows the word if. So the word if is not any part of the hypothesis. So in that case, what's the hypothesis?
The forecast is rain.
Forecast is rain. All right? What's the conclusion? I will take an umbrella. It's that simple when the statement is in if-then form. It gets a little bit confusing when you get a statement like a number. Is divisible by 10. if its last digit is a 0. Now, when you're asked to identify the hypothesis and the conclusion, the hypothesis still follows the word if.
It's just flipped around.
It's flipped. All right, so after the if is, now look, here's where you got to kind of use, I'm not going to say common sense, but you need to think a little bit. You're talking about the hypothesis or listing the hypothesis. So if you're listing the hypothesis here, and its symbol is the P, okay? The hypothesis, you're not going to say its last digit is a 0, right? Because you have to determine what you're talking about. So a number's last digit is 0. That would be your hypothesis, all right? A number. A numbers. Make your sentence make sense. A number's last digit is 0. And if you use the highlighters, this is a really good section to identify your hypothesis and conclusion in different colors. The conclusion of this statement, that's the Q. In this case, there's nothing following the then. But by process of elimination, if what follows the if is the hypothesis, then isn't the number being divisible by 10 the conclusion? Okay, so your conclusion is that a number is divisible by 10.
So if it just had the if, like if it just had the P, then it would be okay to just write the conclusion as the answer or something.
Depends on the question.
Yeah.
It depends on the question. Typically in this section they're asking you to identify the hypothesis and the conclusion. So what follows the if is the hypothesis. The rest of the statement ends up being the conclusion. But when you're writing your hypothesis and your conclusion, I want you to write it in a sentence form or have a structure that makes sense. I don't want you to... The hypothesis in this case would not be its last digit is a 0. A number's last digit is a 0. Understood? Okay. Your assignment for today, then, is going to be on page 107. I want you to do 1A and 1B. Page 108, 2A and 2B. And then on page 111, you got 4 problems where you're going to identify the hypothesis and the conclusion, and then 4 more problems where you're going to write each statement in if-then form. Okay? So it's going to be easier for you to just read example 2 than it is for me to explain it. So on page 111, you got problems 1 through 8. Check your odds in the back of the book. And deadline for homework.